Hey everyone, and welcome to today's Explainer. I'm absolutely thrilled to be your guide. Think of this as our own virtual math classroom, because today we are tackling the very first chapter of the Class 9 math syllabus. And hey, whether your school follows the CBSE board using NCERT or the ICSE board, don't worry, the foundational concepts we're exploring today overlap perfectly. We're going to take a supportive, step-by-step journey to unlock the entire number system. So let's just dive right in. All right, here is our game plan so you know exactly what's coming up. First, a welcome to real numbers, followed by rational versus irrational numbers, converting decimals to fraction form, finding numbers between numbers, and finally, 5 practice problems to really lock it all in. Let's get to it. Section 1, welcome to real numbers. Now, I want to reassure you right off the bat, we're starting from very familiar territory here before we expand our mathematical universe. You honestly already know more about this than you think. So the absolutely crucial starting point is understanding what real numbers actually are. I want you to think of real numbers as a giant umbrella. Underneath this umbrella sits literally every single number we are going to work with in our syllabus, right up to the 10th grade. Basically, if you can picture a number line and you can place a dot on it anywhere, that number falls under this umbrella. It's the complete set encompassing both rational and irrational numbers. Let's quickly recap the basic building blocks under that umbrella, just to build some confidence right at the start, because you've been using these for years. Natural numbers, those are just your everyday counting numbers, starting from 1. Add a 0 to that mix, and boom, you've got whole numbers. Throw in the negative numbers stretching infinitely to the left on your number line, and you have integers. You already know these perfectly. Now let's see how this builds into our next big concept. Moving right along to Section 2, rational versus irrational. This right here, this is the main event of today's class. We're going to learn exactly how to spot the difference between the two main families of numbers living under our real numbers umbrella. On one side of the family, we have rational numbers. These guys are predictable. They're highly structured. Basically, any number that you can write in a p over q fraction form, where q, the denominator at the bottom, is not 0, is rational. Even a whole number, like, say, -2, is rational, because you can just write it as -2 over 1. Make sense? But on the other side, we have irrational numbers. These are totally unique. A really quick way to spot them is that they are the unbreakable roots of non-perfect squares. They simply cannot be written in that neat p over q fraction format. No way. Now check this out. Notice how we can classify numbers just by looking at how their decimals behave. If you divide 2 by 5, you get exactly 0.4. It stops right there. It's terminating. That means it's rational. If you divide 1 by 3, you get 0.333, and that just keeps repeating forever. It's non-terminating, sure, but because it repeats a pattern, it's still rational. But look at that bottom row, 1.7389, and so on. It never stops, and it never ever repeats a pattern. It's non-terminating and non-repeating. That absolute chaos, that means it's an irrational number. Okay, we also have the square root test, but I really have to warn you about the root trap. Just because a number has a square root symbol over it, that doesn't automatically mean it's irrational. If the number inside is a non-perfect square, like 2, 3, or 5, then yeah, it's stuck trapped in the root, and it is absolutely irrational. But if you see the square root of 4 or 16, wait a minute, those are perfect squares. They escape the root to become 2 and 4, making them perfectly well-behaved rational numbers. So rule of thumb, always check if the number can escape the root. All right, let's step into Section 3, decimals to fraction form. We just established that repeating decimals are rational, which means they can be written as a fraction. Now I'm going to show you a super clever mathematical trick to actually convert those infinite repeating decimals right back into that simple p over q fraction form. Here is our first procedural problem. And hey, don't worry, we're going to solve it together step by step. I want you to convert 0.222 repeating into a p over q fraction. So how exactly do we capture infinity and somehow turn it into a simple fraction? Well, here is the brilliant logic behind it. Step 1. We set our unknown fraction to x. So x equals 0.222 repeating. Let's call that equation 1. In step 2, we multiply both sides by 10. Why 10? Because multiplying by 10 shifts the decimal point exactly one spot to the right. So now 10x equals 2.222 repeating. That's equation 2. Step 3 is where the magic really happens. We subtract equation 1 from equation 2. 10x minus x leaves us with 9x. And 0.222 repeating minus 0.222 repeating, it completely cancels out that infinite repeating decimal tail. Just wipes it out. We're left with just 2. Finally solve for x, and you get 2 over 9. See that? We just literally captured infinity in a fraction. Let's level up a bit with a slightly more advanced example. We're going to convert 15.171212 repeating. In this case, the 12 is what repeats. If we only multiplied by 10 here, the decimals wouldn't align properly for subtraction. Because 2 digits are repeating, the 1 and the 2, we have to multiply by 100. So 100x equals 157.21212 repeating. When we subtract our original x from this, the repeating 12s perfectly line up and totally vanish. 99x equals 1555.5. To clean it up, we remove that one remaining decimal point by adding a 0 to our denominator, and we simplify that to 15,555 over 990. Pretty incredible, right? Okay, moving on to section 4, numbers between numbers. This is where we visualize our number line again and realize that between any two numbers, there are infinite gaps. We're going to explore how we can find hidden values, no matter how incredibly tiny the space is between them. To find those hidden numbers, we use 2 specific formulas. If you want to find a rational number safely tucked between the integers 2 and 3, you just find the average. Simple as that. Add them up and divide by 2. 2 plus 3 is 5. Divide that by 2 and you get 5 over 2, or 2.5. Easy. But what if you want an irrational number exactly between 2 and 3? Well, you multiply the two numbers together and trap them under a square root. 2 times 3 is 6. So the square root of 6 is a perfect irrational number sitting right there between 2 and 3. But what if you need to find irrationals between two decimals, say like 0.12 and 0.13? Honestly, this is actually the easiest trick of all because you just get to invent them. Since an irrational number in decimal form is just non-terminating and non-repeating, you start with 0.12, pick a digit to make it slightly bigger than 0.12, let's go with a 3, and then just write out a totally random string of numbers that never ends and never falls into a repeating pattern. 0.123267009. Boom! You just crafted your very own unique irrational number right inside that tiny gap. And finding irrationals between fractions, it's exactly the same process once you know the secret, which is just to convert the fractions into their decimal forms first. 1 over 7 becomes the repeating decimal 0.142857, and 2 over 7 is 0.285714. Now your job is exactly the same as the last step. Pick a number greater than 0.142 but less than 0.285 and just make it absolute chaos. So something like 0.1433033 and so on works absolutely perfectly. We can even do the reverse magic. We can find a neat, well-behaved rational number wedged right between two chaotic irrationals. Look at 0.232323 repeating and 0.25555 repeating. What's a nice, clean, terminating decimal that sits right in between them? 0.25. It is a perfect terminating decimal, a perfect rational number, finding a peaceful little home right there between all the chaos. And here we are at section 5. 5 practice problems. As your teacher today, I gotta remind you that math is definitely not a spectator sport. It requires action. So now it's time to put today's structured lessons to the test, all on your own. All right, here is your homework, drawn straight from today's formulas. Grab a pen and please write these down. Number 1, identify if the square root of 9 is rational or irrational. Remember the root trap we talked about. Number 2, classify 0.333 repeating as terminating or non-terminating repeating. Number 3, convert 0.555 repeating into that P over Q fraction form using our cool algebra trick. Number 4, find one rational number exactly between 4 and 5. And number 5, invent your very own irrational number between 0.15 and 0.16. I highly encourage you to really lock in your knowledge by tackling these 5 sums today. The concepts of rational and irrational numbers, these are the fundamental building blocks for literally everything that comes next. So are you ready to say yes to math and conquer these practice problems? I absolutely know you are. Get those done and you'll be completely prepared for our next step. But before we go, I want you to picture a simple number line, or even just look at a ruler, and realize this. Between every single tiny millimeter mark, an entire infinite universe of numbers is hiding. What happens when we zoom in forever? Ponder that little puzzle, and I'll see you in the next explainer.